Good afternoon, everyone. So we looked at various different ways of testing software. We looked at testing infrastructure. We looked at quality assurance. We also, last week, we looked at quality standards, things like ISO, CMMI, things like that. Now, today, we're going to look at another very interesting area. This is automated testing, or we call it test automation. Now, all this time, we were talking about various concepts of testing, isn't it? We looked at test-driven development, unit testing, and system testing, integration testing, all kinds of testing. We realized this testing is required to assure the quality of the software. So that's where the quality assurance is coming in. So today we are going to look at how we can automate some of these testing. Because as you notice, you need to write a lot of test cases, and then you need to run them manually also. As in, you have to run this command manually. It's okay, but then when it comes to very complex software where there are a large team of people working and where you want to automate the deployment faster rather than waiting everyone to do their testing and then somebody else again testing manually, what we can do is we can get all the test cases automated, as in let the developers write the test cases and then get another software system to run the test cases and then figure out what is failing. Okay. So under this, there are so many different things: mobile app testing, web-based app testing, simulation, form simulation, and things like that. So let's see how this works. Now, along with this automated testing comes another very interesting topic, which is very famous these days, right? CI/CD, continuous integration, continuous delivery. Now, along with that comes another famous job role called the DevOps, right? Development and operations working together. So test automation is a foundation of all those other topics. We're going to look at this today. And hopefully we'll also look at the rest of the topic as we go along, right? So test automation, what is this? Let's look at a definition first. Developing software to test the software. So we are already developing software to do some action. Now, on top of that, we are developing other additional software so that we can use this additional software to test the software we are writing. So this is called test automation, okay, or automated testing. Now, when it comes to test automation, there are lots of tools available. So in fact, what I've done here is I have broken down into some categories. So it's easy to understand. Depending on the category of your software, you can choose which software is more suitable for the project. So how do you select the most suitable software for this, right? Remember, we are writing our code using some sort of language, maybe Python, C#, PHP, Java, anything for that matter. So there are tools that are more familiar with this kind of language. So there are language-specific tools, then there are generic tools that can be used with any language also, right? So for example, if you're doing form simulation, so there's a form online, you want a test application to fill the form, press the submit button, then look at the output and things like that. So then it doesn't matter because it's not language dependent, it's language independent. Okay. So if you're looking at selection criteria, we are looking at clear and reasonable expectation. So looking at the criteria, clear and reasonable expectation should be established in order to. So, I mean, we have certain expectation, isn't it? So when you are selecting a tool, so we need to know what do we want from this tool. And then also clear understanding of the requirements. Now, when you are building a software, remember we looked at how we get the requirements. So we work with our customer and then there's a BA team writing down what the customer wants. And then that gets translated to a SRS and then comes to the development team. And then the development happens. While the development is happening, we have certain SQA, software quality assurance standard, that is coming into place. And while developing the software, we also developed the testing criteria. Okay, so understanding the requirement is very, very important. Okay, and then so the organization should have detailed, reusable test cases. Now, we spoke about test cases, right? So unit testing, system testing, integration, stuff like that. So we need to have a very clear understanding of the test cases. Sometimes we can reuse it. Now, for example, if you look at a very common thing, login screen, right? Under that, we have login, registration, password forgot, then remember me function, stuff like that. So those are available pretty much to every software we are developing. So if you have test cases done for this, then you can use it for all the application out there. So that is why you say reusable test cases. And also, remember, when it comes to testing, we generally don't use the production database, right? In fact, if you look at some of the test cases, we created test database in memory, in RAM, not even in the hard disk, right? So that way, our test cases run very fast, number one. Number two, once you get out of the test cases, the database is no more because it was running on RAM or memory. Is no more there, right? So speed is very important because you're running thousands of test cases sometimes. So accessing the hard disk might be slower. Accessing database from memory is the fastest way of doing it. Next one is how much expensive the test software is. If it is very expensive, you need to be able to justify, okay, why should we use an expensive software, right? You notice I'm having a list of tools available right now. There's a massive list of open source software tools available as well. So maybe some of them are okay, right? Maybe not. So it depends on the company, depends on affordability, depends on training you have, things like that. Okay. So, and also remember now, when you're selecting a testing tool for an organization, you're not going to use one tool for one project and another tool for another project. Not really. You are going to get stuck with this tool for a long time, for a couple of years. So before you select a tool, you need to do some homework and then select the right tool. Don't maybe select the popular tool. Look at what is best for you, right? For your team, for the organization, for the language, and also kind of software you are building. So it's very important when it comes to these selection criteria. Now let's look at the advantages of automated testing, right? What are the advantages? Now we already looked at manual testing and writing cases and all that. So what are the advantages? Number one is speed, isn't it? Way faster than manual execution. So if you are doing manual execution, you may have to run code or instructions every now and then to multiple modules, maybe, or multiple systems, maybe, or multiple people may be running manual execution. So, but if you automate it, everything can be run at once at the same time, right? So, of course, the developers must write the test cases, but running the test is what we are trying to automate. If you do automated testing, then the developers do not need to worry about who's running, what to run, and they might even miss certain things, right? So you can free them. So they can then look at doing other tasks, right? Plus, automated testing is reliable compared to manual testing. Less chance of human error, isn't it? So if humans are involved in anything, there is a tendency of introducing error. So same goes for testing. And another thing is you can do the testing immediately. You don't need to wait for anything else. You can have it immediately, right? So bottom line is automation equals less person independence, right? Or less person dependence rather. So we are independent because of the automation, right? And also, if you look at some of the testing cases, if you noticed previously, like reliability testing, stress testing, load testing, and also performance testing, most of these things take a long time, right? And also, even sometimes not possible, not practical for humans also. Now, for example, if you are doing load testing, you may need to create about 100,000 accounts. Now, manually creating that is impossible, right? So you can automate that task and get it done, right? Plus, automated testing can be done any time of the day, whereas manual testing can be done only during the work time, right? So another big one is resource requirement for automated testing, right? Now, if you look at people-wise, you need to, if you, let's say, for example, you want to calculate the amount of resources required for testing a software, yeah? If you calculate the manual task, you will need to calculate number of people, number of heads, and then the time, the desk, computers, everything else. Whereas automated testing is just scaling up. You create one case and then just scale it up to 10, 100, 100,000, 1 million, no problem, right? So it's very easy to scale up, right? And also, you can have a repository of test cases, like I said earlier, the login screen testing, right? So that can be stored so that you can test it for or use it for multiple projects later as well, right? And the last point says automation does not end with developing programs for the test cases. It doesn't end there. There are so many things. Like I said, there is a CI/CD, there is DevOps, there is DevOps security. So there are so many things that is actually depending on automated testing as well, right? So it's not just one thing that we are talking about here. So just like the advantages, there are also a few disadvantages, but I think advantages are much better. So because of that, we go with that. But then if you look at some of the development of test suite, right? It does take time. So you have to have special people, specially trained. You can't expect, let's say, the same developers to do the same, right? That's actually extra work in the beginning, but once you get your test cases done, then it's automated. You don't need to do it again and again and again. Yeah. So you have to train your staff and maintain these people, and also they need to have continuous work, right? Now, in many places, they don't treat test automation as a serious matter. But then long term, you're going to save a lot of time, a lot of money, and a lot of embarrassment from customers, right? For management, they wouldn't understand. So some people, some management think that testing should be done by the developers. So if something breaks, then it is the developer who's responsible, right? Yeah, developer is responsible, but then you could have prevented that by testing, yeah, which requires additional staff. So that might be a negative point. But remember, long term, it's always good to do the testing before you release it to the customer. All right, so how do you select, right? There are different ways of selection too. So there are, in fact, different ways of running this automated software. The first one is called capture and playback kind of testing. And we list it under first generation. These are the oldest tools. Yeah. So you run the software, you record what is going on, and then you understand what happened. Something broken, something working, things like that. Now, under that, there are two ways: intrusive, non-intrusive. Intrusive meaning, if you remember breakpoint, we wrote a little program with Java and we ran a breakpoint, right? So under that, we stopped the program and then we looked at the variables, there's something called watch window. So under that, we can look at the variables, what is happening, what is changing, what is not changing, things like that. Non-intrusive is where you let the program run and maybe you push something to the console or to another log file or something, and then you study it, right? That is non-intrusive. So you're not stopping the program. Program is running, but at the end, you look at the environment to understand whether everything is fine. Then we have data-driven second generation, where you have data that is working together with the software to understand how the software is performing. For example, like the simulation, yeah, where you have a form and then there is a piece of software that is loading data into the form and then looking at what is coming outside. So that is a little more automated than the previous first generation testing. And the third generation is action driven, where you can do all kinds of stuff, right? You can have a test program written separately along with the actual program. So they run together, for example. And you can also have actions, like if something goes wrong, what to do, stop production or roll back to previous state, things like that. So the third generation is much more sophisticated. And we remember we also spoke about debugging before, and I think we discussed this exact thing previously as well. So what is testing? What is debugging? There's a huge difference between these two, right? So testing is where we are executing a program with the intent of finding fault. We don't know whether there are any fault. We are trying to find a fault. Whereas debugging is an activity to location and correcting errors. So we know there is an error, we found it, and then we're trying to fix it. That is debugging. Number two, it's a phase of software development lifecycle, software testing, right? Debugging happens because of testing. You test and then you have to debug, right? Number three, once code is written, testing commences. So once the code is done, you start testing. Whereas the debugging process begins with the execution of a test case. So you run a test case and then you debug the code. And number four, further comprised of validation and verification of software. So remember, we have V&V, verification and validation. That's the software testing case. But when it comes to debugging, we are trying to match the symptom with cause. That is, we look at some output and then we're trying to figure out, okay, this output came because of what, right? Thereby leading to error correction. And last point is it uses unit integration and system level testing when it comes to testing, whereas debugging checks the correctness and performance of the software. That is debugging. So this chart essentially shows the flow. Yeah. So we start with the software under test, right? And so, of course, we start with some test cases and we run the test case, we execute the test case, we look at the bugs. If there are any, we identify the bug. Then we try to find out the reason or the cause identification. And then we try to figure out, okay, explore the correction, how to correct this. And then figure out selection of corrective action. Then we correct it and then we put it back to testing. So that is called regression testing, testing again on the same sort of condition, same environment, same scenario. And it goes on until the software is fully functioning. Right. Now, what are when it comes to, designing and architecting the software, so what are some of the steps required to do that? Step number one is identify your test suite requirement. What does that mean? Now, we have certain requirement ourselves, right? We call it the generic requirement. And then our test suite, our test software has its own requirement. So we have to first identify both separately. And step two, make sure experiences discussed in previous sections are taken care of. So this is the learnings from the previous time. So you learn from the previous time and then you bring that lesson to this new test case. And also we can look at what other people, other organizations, other departments, other software, how have they used this software tool? Because, remember I said selection of the software is not a easy task. It's a long-term thing. You need to make sure you are collecting and using the right tool. If you are using a new tool, or actually this is also for the software itself, you need to have a checklist of questions, right? If something goes wrong, okay, what to do? If you want to do this thing, how do I do this, right? So that kind of question you need to ask and make sure that there is some sort of support system available for you. And then when it comes to selection, we need to look at, okay, what tool is supporting our requirement, right? So we had our own list of requirements. Which one is supporting our one? And then you shortlist them And once you shortlist, you train your developers, actually testers in this case. And once everything is done, that is identification of the differences, finding the answers to your questions, and training starts after that, right? So you train all your testers, the QA engineers of this new tool, and you deploy the system. So they'll write the test cases and start testing it, and the whole automation will start kicking in as well. Right. So remember, I told you there are so many tools out there when it comes to automated testing. And what I did was I broke it down into about 7 different categories. Of that, we are going to look at the first 4: functional, performance, API, and mobile testing. And I combine the last 3 together separately. So we will be looking at CI/CD separately, and also BDD and AI and ML-based training, rather testing separately. Okay, so I want to keep it simple today. Right, so let's start with the first one. Functional and UI testing tools. What are these? Remember, under the SRS stage, we wrote down the functions, features, use cases of our system. And then we also designed the user interface of our system, right? So now we need to make sure our functions are working and our UI is working. Okay? So the goal is that exactly to see whether functions and the UIs are in fact working properly. So here are some tools that are used by the industry. One of the most famous one is called Selenium. Remember, it's an open source tool, so it's not to be purchased, it's free, right? So it's for automating web browsers. Now, this will simulate a human using an application. So you can use it with anything because it's not specific to a language. So you may have used Java, C Sharp, Python, PHP, whatever to develop your application. You can use Selenium to test your online forms, right? And also, it doesn't matter what browser you're using, whether it is a Chrome or Firefox or Safari, Edge, anything works, right? And also on multiple operating systems. Now, if you have source code testing tools like Jenkins, Maven, Docker, and whatnot, Docker is another virtual environment. Selenium works with them as well, pretty well, right? And then there is Selenium WebDriver for detailed interactions. Now, I'm not going to use any of these tools. This is for you to understand what options are available in the industry and in the market. When you join a company, they may be using Selenium, they may be using something else. And then you need to at least know, okay, these are the tools used by automated testing environment. Right? So Selenium use case is suitable for web application testing, including regression, functional, and UI testing. So this is also for UI testing. Right? Next one is called Cypress, another modern web design, a web testing tool for QA engineers, right? It's pretty easy to set up. That's why it's also famous among many people. And also have a lot of debugging capabilities, right? This also, like Selenium, works on the browser itself. There is something called time travel, where you can go back in time. Say, for example, in a login environment, what happened after login, what happened before login. So you can go backward step by step as well, right? And also, sometimes, especially when it comes web, when you are logging in, it will require connecting to a server and downloading certain things. So we can automate that part as well. Okay. So later I will talk about the CI/CD pipeline. Now Cypress has a direct connection to CI/CD as well. Now remember I said automation testing is part of the continuous integration and delivery. So if a tool has the capability, then it is much better than a tool that does not have. Okay. So
This is suitable for modern web application testing on the browser. Another one, a famous one, is called Playwright. Right? This is from Microsoft, by the way. And it also works on multiple browsers. Any browser, it's not a browser specific thing, right? And it can handle multiple tabs. That's another very interesting one. It can handle multiple tabs on the browser, multiple frames, and also browser context. Meaning, when it comes to web-based application, we have something called session. When you log into a server-side application, you are given a session. So we need to know whether you are in the session or not in the session, right? It's important because when you are creating one test case, you are creating one session. When you are creating another test case, you have a new session. So that you need to keep in mind. And your automated testing tool must take care of that automatically. Okay. And then it also has web element management. Now, stuff like React, for example, or Vue has component on the web. There is a website, but within the website, there are components like button can be a component, the section can be a component. So sometimes when it comes to testing, you may have to test the component separately as well, right? But of course, on the website, everything works together in harmony. So Playwright is suitable for end-to-end testing of complex web applications. Next up is Test Cafe. Another one, another end-to-end testing tool. And this one works without a browser, right? That's also interesting because you don't need a browser. It uses built-in communication with the backend and then download information, processes itself, and then gives us screenshots and detailed reports. Okay. So since it does not use a browser, some people like that because it's pretty straightforward and okay for testing a web-based application. Now, of course, there's another method later we'll be talking about it called the API testing. This is not API testing, right? This is basically testing the web-based application without the browser. Another famous one is called Catalan Studios Catalan application, right? It's actually all in one. You can use it for web application testing, API testing, mobile testing, as well as for desktop application testing, right? And it can also record and playback. So this is a very powerful application, right? And also can be used for data-driven testing. Remember, third generation tool. So this is a third generation advanced tool. And then it also gets integrated with Jenkins, Travis, Circle CI, stuff like that for CI/CD. Okay. And this is best for teams looking for a comprehensive solution to automate testing across various platforms. Again, comprehensive. Right. So with that, let's come to the next type of tools, performance testing tools. So we looked at feature testing. Now we are looking at performance testing. So what do you mean by performance? So application must have features, yes, but it at the same time must be working within the speed, the scale, and the stability. All that is also important, isn't it? So how do you check the bottlenecks of an application? That's what we're trying to do here, right? So let's say we are building an e-commerce application and we are expecting about 1,000 people every week. 1,000 weekly, maybe monthly. We're expecting, depending on certain special days and holidays, this 1,000 can hit sometime 10,000. So you might have a spike of 10,000 once in a while. During special holidays, like let's say Sinhala New Year during April or Christmas time, you might have 25,000 hits coming. So can you simulate this 25,000 load? Right? Then we know exactly whether our software will work during Christmas or will break during Christmas. Yeah. Now for that, the first tool that we can use is JMeter. This is for load testing. And of course, there are lots of different protocols it supports: HTTP, HTTPS,
Then there are so many others like JMS, SOAP, LDAP, right? All these keywords are for various protocol to connect to the database and the application server at the back. One of the plus points here is that it provides a graphical interface for creating test plans and also to analyze results. We can also use it for distributed testing, meaning multiple servers testing our application as well. And lots of support for CI/CD and also extensive plugins available for extension of the features. So this is suitable for load testing, API testing, plus overall performance measurement. So this is another very famous open source tool from the Apache group. Next one is called Gatling, another famous tool, also open source by the way, very efficient and suitable for modern web applications, right? So with this, we can do some high performance testing and we can simulate thousands of users. And it also provides something called the DSL, domain specific language for defining test, right? So there's a language called Scala, another AI type of language. We can write our test cases with the domain specific language. Like say, for example, say we have an accounting package, right? So we can write the test cases using the accountant's terminology, like invoice. Invoice must have, let's say, a payment, or the other way around. We can say a payment voucher must have an invoice. So we write it with the accountant's language, right? And that can be loaded to Gatling. And it also gives us a very interactive, beautiful HTML report once you do the testing, right? And this is good for stress testing as well as for API testing. And the other one is from Grafana, K6, another very famous tool. It's also good for DevOps practices, that is like complete integration of the deployment. You can have K6 there, right? And one of the advantages in this one is it uses JavaScript for coding. So you can also write some code using JavaScript for your test cases. And it's very lightweight. The installation is not heavy, so very light to run. And also, since it's JavaScript based, information comes to you as real-time detail metrics. And also, you can have a cloud-based distributed load testing. So like the previous one, you can have multiple ways of testing it there, right? So suitable for web applications, APIs, and also CI/CD workflow testing. And the next one is BlazeMeter, another famous tool. It supports JMeter, Gatling, and so many other testing scripts that is coming from the previous tools. So it's compatible with other tools. And this is suitable for large-scale testing. Now, let's say you have Gmail. You want to test Gmail, for example. You are Google, you want to test Gmail. There are like millions, in fact, billions of people using the solution. So you need a similar large-scale testing platform for testing it, right? And it gives a detailed reporting and analytics at the end. It also works together with the other tools like Jenkins, Bamboo, TeamCity, stuff like that. So it's suitable for mobile application testing, web application testing, and also for API testing. Next up, we have Load Run, another comprehensive tool from Micro Focus.
So very similar to the previous ones. It again has distributed load testing, right? I'm just introducing you to the tool. So if you need more information, you can always go to the tool, read about it, study that, and then see how it can be used. Another tool from Apache is the Apache Bench, a benchmark, or Apache Bench, we call it AB. This is for usual, standard web servers, right? Very easy to use. But it's very basic when it comes to metrics, right? If you want to do some quick and dirty sort of testing, well, AB might be a good case. And another one is called Locust, right? User behavior testing, this is. Uses Python for writing test scenarios, making it easy to extend and customize. So if you are into Python-based application development, this might be the best one to go ahead with. Very scalable and also has lots of capabilities. You can have millions of users using your Python application, and the performance can be, received real time as well. And the next one is Neoload, another very famous tool. This is also good for continuous performance testing, right? So not just one test done, you can use it for continuous testing. And has a lovely graphical interface. So there are a lot of automatic test design, maintenance, writing test cases is a huge scenario. In fact, we said that was as a disadvantage. But of course, you can use tools like Neoload to get it done faster. Right. So with features and the others, we now come to our third platform, which is API testing tools. Now, what is an API? API stands for Application Programming Interface. We use API to interconnect different software together. For example, let's say I developed a tourism application and I want to have currency exchange information up to date, meaning I can't load the dollar rate every day morning, right? I should be getting that from a reliable place. The best reliable place would be the central bank of the country because they are the ones deciding the rates. So if the Central Bank of Sri Lanka, for example, has an API engine where I can connect and ask, let's say in the morning, what is your USD rate, USD LKR rate? I can read and then I can update my database or my application. So if you are developing the central bank's application, you need to expect about millions of hits every day, all the time, right? So you need to, of course, do a test and see what is your peak. And then this is API testing, right? How many requests are coming and how much load it is using from our servers. And then where do we break? Okay, can we run 1,000 per second, 10,000 per second, or 1 million per second, right? So that is what we do with the API testing tools. Right. One of the most simplest one and also famous one is called Postman, right? It's a very simple application that you can install. It's free, very functional, and also has lots of features on it. You can use it for simple things like REST-based application API consumption, or you can also use it for other advanced things like automation. You can have a collection of APIs. You can have environment variables to go along with the request, right? Then there's another one called mock servers, meaning you can simulate the API responses. So especially when you're developing the API, you might need that, right? And also monitoring, for example, whether the server is down or up and things like that. And sometimes even performance, we'll see that in a minute, that also can be done using Postman. So these are very
quick to run, very easy to learn tool. We'll see whether we can use some of these tools with our application. Right. The next one is SOAP, right? This is, I think it was developed by Microsoft, something to go with REST, but its own way of doing it. So I think stand for Simple Object Access Protocol. This is again for integrating multiple platforms. And SOAP uses XML files for exchange, whereas REST API uses JSON file. That's the biggest difference here. So SOAP UI is for functional testing, APIs, and also for load testing, security testing, plus data-driven testing as well. Assertions are where we run something with some data, and then we expect certain things as output. So SOAP UI is like the Postman, but for SOAP protocol. And another very famous one is called Swagger. It was also known as the Open API specification. We will be writing some code later with Laravel to see how we can get Swagger working. Now, Swagger is on one side a specification, right? So when it comes to designing your APIs, Swagger will automatically generate the API documentation for you, right? And at the same time, it will also generate the test cases for you. So you can go to the documentation and run the test within the application as well, right? So it's a very, very interesting tool. So there are a few basic things you must know as software engineer students. One is Postman and the other one is Swagger. We'll use them in the class. And another one is called Insomnia. Very powerful, but at the same time, user-friendly API client for testing and debugging. So like Postman, you can create it. You can create request. You can also have environment variables. You can use it for authentication. In fact, you can also have some JavaScript if you want to automate and do some scripting yourself. And plus, it has plugins, right? So you can extend the functionalities. And this is especially for macOS. It was called POW or PO before, but now it's called Rapid API, right? So it's an API client for macOS. And this is for like native experience on Mac. So if you are into Mac-based application development, then this is a very, very good tool to test the APIs. So you can have dynamic values, environment values, so you can generate code for various programming languages. And also, of course, it has extensions, plugins. And again, Apache JMeter. I think we saw it previously as well for function testing. We can also use it very well for API testing as well. Right? Oh, by the way, it uses Groovy for scripting. Remember, the other tools use JavaScript. Now, this one uses Groovy. K6 again, I think we discussed that previously. K6 can be also used for API testing. And another one, we saw Postman. Okay, here's Postwoman. It's called Hopscotch now. It's again free lightweight API request builder. So it allows you to build the request nicely. Now, when you learn about API management, REST is the fastest sort of protocol to use. Of course, like I said, Microsoft users use SOAP. But then when it comes to generating the test cases and also generating the API, generating the API documentation, that requires some time. So any tool that is helping you to do this is always welcome, right? And also, look at the last point, it supports GraphQL as well. Now, GraphQL is a very interesting way to communicate with things like Microsoft 365 Office, Facebook, and things like that, where you can get one and then all the connected things, like say you request one person And you can ask, okay, give me the information of all his friends and their interest, right? Or who like cars from this friend, things like that. So if you are to do that using standard SQL, it's very, very complex. But using GraphQL, it's very simple. And also it supports WebSockets. Now, WebSocket is a very fundamental way of talking to other network servers. That also is possible with Hopscotch. Then we have another one, REST assured, right? This is Java-based testing suite for RESTful web services. That is again integration, right? So you're using API to talk to other servers. And it uses domain-specific language. Remember, we saw this previously as well, yeah? So like the accountant using accounting terms. Very easy to integrate with others like JUnit and TestNG for C# and Java. And also have something called assertions, where you give variables and then you verify the output of that. Right. So with that, we come to our fourth type of testing tools, mobile app testing tools. So what does this mean and why this is different to other testing tools? They are specifically designed for mobile applications, right? Because if we look at the environment of web-based application, which generally run on a laptop or a desktop, yeah, versus desktop application and mobile application. So mobile phone has limited screen size, limited network speed, limited capacity, right? So things like that. So when you are testing it, you need to simulate all that, like lower speed, lower capacity, stuff like that, and then see whether a large number of our people, now, of course, there are people who are running very powerful mobile phones, but the large number of people are running average or below average mobile phone, isn't it? So if you're writing a application that can be used by a large number of people, you need to make sure it has a bigger support for large number of people, right? So right now we have two platforms, Android and iOS. So the first one in our list is Appio, right? It's a open source tool. Right? It's an open source tool. It supports both native, hybrid, and mobile web applications on iOS, Android, and also Windows platform. Now, Windows Mobile is no more use, but this used to be supporting that as well. So, cross-platform testing and multi-language support. Right? So, Java, Python, JavaScript, all that is supported. It also has a web driver protocol, just like Selenium, if you remember. So you can automate web browsers if you're using a web browser. And you don't need to have test source code of the application, right? You can have, you can basically simulate the mobile phone. Next one is Espresso, right? It's another mobile testing tool, but this is specifically for Android, yeah? I think it's old. There are new tools available now for Android from Google. Very fast and reliable when it comes to UI testing. And it also has simple API testing as well. Synchronization is another interesting feature when it comes to mobile application, because if you don't have the internet connection while you're working on the mobile phone, you need to make sure you store the information. And when you go online, you have to synchronize the data from the mobile phone to the server. Okay. And it works very well with the Android Studio, which is the IDE from Google for Android development. And then it's good for UI testing, API testing, and also for load testing. when it comes to mobile applications. Next one is XC UI test, right? This is from Apple when it comes to UI component testing, right? So it has a native integration with Apple. Now, if you have done any development on Apple, you remember you must have an Apple hardware. It doesn't work on any other hardware. And then you have this program called Xcode, like the Android Studio on Mac, it's called Xcode for all the iOS-based application development. So this tool also works on top of that to check out the mobile application and the UI on Apple. And then next one is Test Complete. Is another, this is not open source, by the way, it's a commercial application for web, mobile, and desktop. So cross-platform testing. There are scripted and scriptless testing, and also visual object recognition. So it has certain advantages where it uses object recognition and also parallel execution. So you can have multiple devices running at the same time. Okay, so if an organization uses or rather required a very complex set of tooling or rather testing tools, this one is very good there. Next up is Ranorex, another commercial test automation tool. Cross-platform, again, very easy to use, can integrate with other tools, and also has a comprehensive reporting engine, also suitable for large team. And the next is Calabash, right? Another open source one for both Android and iOS. So there are lots of integration available again here. And it uses a natural language style test case writing, right? So there's a separate one called Cucumber. So it uses natural language style writing there. And then it has rich set of APIs suitable for cross-platform testing. And later we'll be looking at another concept called behavior-driven development. So behavior is where you're looking at how a certain user behaves, right? So we can map that behavior into our testing. And then another famous one is Robotium. Again, this is for Android application development, testing. Also for black box testing. Remember black box, where the tester doesn't know how things are working. And so the platform will take care of that. Okay. So it's very flexible, easy to use, and also integrates pretty well with many other systems. Right. So today we looked at part one of test automation. Remember, there are a few others as well when it comes to test automation. Next week, hopefully, we will look at that. So we looked at ways of selection. By the way, this is the chapter you need to refer to, chapter 11, the test automation. So the tools that I showed you are currently available tools. Most of them are available and used by the companies, right? So we were able to categorize them as per this, right? Functional-based tools, performance-based tool, API-based tool, and then mobile-based tools. So next, we will look at CI/CD, behavior-driven development, that is BDD, and also how AI and machine learning can be brought in for testing as well. So that will be very interesting because these days everything is AI-based. But just not for the sake of AI. There are things we can use AI for when it comes to software testing. All right, I'll see you around next time.